Okay, let's dive right into this. Welcome to The Explainer. Today, we are going on a really fascinating journey to uncover the layers of human intelligence. We're drawing directly from some incredibly compelling academic material, specifically the fantastic research and lectures curated by Dr. Sarah Butter. Now, we throw the word smart around all the time, don't we? But what does it actually mean on a clinical, psychological level? How do we even begin to measure it? And perhaps most intriguingly, what are the biological and environmental forces that actually shape the power of our minds? Well, let's peel back the layers and find out. I want to hook you right away with a seemingly simple question. What actually makes someone smart? Take a second and just ponder your own definition. Is it being able to solve complex calculus equations entirely in your head? Is it having this vast Wikipedia-like mental encyclopedia of historical trivia? Or maybe it's the ability to instantly read a room and flawlessly adapt to a tricky social situation. We all have our intuitive ideas about intelligence, but before we go any further, we really need to look at how the experts define it. So here is the absolutely crucial point. In psychology, intelligence isn't viewed as a single, tangible, physical object that a surgeon can just locate in your brain. It is defined as a hypothetical mental ability, and I want you to notice the three core pillars of this definition. It's the ability to direct your thinking, to adapt to your circumstances, and to learn from your experiences. It's highly dynamic. It's not just about what you know, it's about how you actively apply what you know to survive and thrive in whatever environment you happen to find yourself in. Right, so now that we know what it is, how in the world do we measure something so hypothetical and dynamic? Well, that brings us to the intelligence quotient, famously known as IQ. Originally, way back in 1914, Stern conceptualized IQ with a very straightforward, if maybe slightly rigid formula. It was calculated simply as your mental age, which was determined by a test, divided by your actual chronological age, and then multiplied by 100 to give you a nice, neat whole number. Today, the mechanics of measurement are vastly more sophisticated. We use percentile rankings that project your scores onto a normal distribution curve compared to your peers. But what exactly are these modern tests asking you to do? Now, what's really interesting about this is how modern testing breaks down into two main buckets. On the performance side, you've got visual puzzles, block designs, and matrix reasoning, where you basically have to figure out the missing pattern. It requires absolutely no language at all, just pure, raw spatial reasoning and logic. Contrast that with the verbal side. That is all about word recall, reading comprehension, digit span, and vocabulary. A truly comprehensive IQ test blends both of these together to get a full 360-degree picture of your cognitive capabilities. And all of that exhaustive testing usually spits out a number that sits somewhere on the famous bell-shaped IQ curve, where 100 serves as the anchor. 100 is the exact mathematical average. The way this curve works is actually pretty elegant. 68% of the entire population, so basically 2/3 of us, falls within one standard deviation of that mean. That means an IQ score somewhere between 85 and 115. If we expand that net out just a little bit further, a massive 95% of the population falls between a score of 70 and 130. Okay, let's zoom out a bit and explore how this builds into broader theories of how the brain works. Because psychologists have been debating the structure of intelligence for over a century now. On one side, we have Charles Spearman's 1904 theory. He proposed the G factor. This is the notion that there is one single, underlying general intelligence that dictates your performance across all cognitive tasks. Basically, if you're smart at one thing, you're generally smart at everything. Contrast that with Howard Gardner's much more modern 1983 theory of multiple intelligences. Gardner argued, no, we don't just have one general bucket of intelligence. We have 8 distinct potentials, things like linguistic, spatial, musical, bodily kinesthetic, and even interpersonal intelligence. It is a totally different and frankly very refreshing way of framing human potential. Here's another incredibly useful way to divide intelligence, Raymond Cattell's model. He separates our cognitive abilities into two types, fluid intelligence and crystallized intelligence. Think of it like this. Fluid intelligence is your raw processing speed. It's your ability to process new information, spot fast patterns, and solve completely novel problems on the fly. Crystallized intelligence, on the other hand, is your accumulated knowledge over time, your vocabulary, your understanding of history, your deep life experience. This is exactly why you might completely destroy a grandparent at a fast-paced, brand-new video game relying on your fluid intelligence, but that exact same grandparent will absolutely crush you at a game of historical trivia, relying on their deep well of crystallized intelligence. Fluid speed naturally declines as we age, but our crystallized knowledge remains amazingly stable. Speaking of aging and intelligence over lifespan, I have to share one of the most incredible longitudinal studies ever conducted in the history of psychology. It was the Scottish Mental Survey of 1932, On June 1st of that year, something totally unprecedented happened. Virtually every single 11-year-old child born in 1921 in the entire country of Scotland, that's 87,497 children, sat down and took the exact same intelligence test simultaneously. It gave researchers an unbelievable baseline of data for an entire generation. But the real magic happened decades later. Researchers actually tracked these individuals down and retested them at age 80. The findings were staggering. First, they found amazing stability in scoring. If you ranked high, medium, or low at age 11, you were highly likely to be in that exact same rank at age 80. But even more profoundly, the test at age 11 was actually predictive of long-term health outcomes. Lower IQ scores at age 11 were later statistically associated with a shorter lifespan, a higher likelihood of developing lung cancer, and a higher risk of experiencing psychiatric illness or dementia. Intelligence, it turns out, is deeply, deeply intertwined with our overall biological resilience. Which inevitably brings us to the age-old debate, nature versus nurture. Are we born with our intelligence hardwired into our DNA, or is it shaped by our surroundings? Well, the short answer is, it's absolutely both. The concept of heritability measures the proportion of variation in intelligence that we can attribute directly to genetics. In the UK, research shows the heritability for intelligence ranges anywhere from 40 to 70%. So your genetic blueprint is incredibly significant for sure, but it still leaves plenty of room for environmental factors to play a massive role. And this leads to a truly fascinating psychological paradox. The more successful we are at equalizing environments, the more genes account for the differences between us. Think about that for a second. If society somehow succeeds in giving every single child the exact same perfect nutrition, the exact same excellent schooling, and a totally safe, stimulating environment, if we level the playing field completely, then the only variable left to explain why one person scores higher on an IQ test than another is their genetics. But of course, in the real world, environments are rarely equal. There are massive external factors that physically shape the developing brain. On the positive side, things like high socioeconomic status, early exposure to an intellectually stimulating education, and proper childhood nutrition give the brain exactly what it needs to build strong neural pathways. Conversely, the environment can severely hinder intelligence. Exposure to environmental toxins like lead and mercury, exposure to certain drugs in utero like alcohol or cocaine, and early neurological injuries or diseases like the Zika virus can absolutely derail a child's cognitive development. Our brains are incredibly sensitive sponges for the world we grow up in. And this brilliantly illustrates just how much our rapidly changing modern environment has impacted our collective brains. This phenomenon is known as the Flynn effect. Over the last century, from about 1910 through to the 1990s, our collective performance on intelligence tests has been consistently, undeniably rising. Every generation has essentially been outscoring the one before it, requiring test makers to constantly restandardize the average back down to 100. But are we actually just getting intrinsically smarter? If we dive a little deeper into the data, a really fascinating clue emerges. Our fluid intelligence, again, that speedy, flexible, problem-solving ability we talked about earlier, has seen the absolute sharpest increase over time. Meanwhile, our crystallized intelligence, our accumulated factual knowledge, has risen but much, much less dramatically. Psychologists believe this is because our modern environment is vastly more complex, visually stimulating, and technologically demanding than it was a century ago. We are literally training our brains every single day to be faster and more adaptable pattern recognizers just to navigate the modern world. So, what does this all mean? We've learned that intelligence is this highly dynamic mix of our genetic lottery and the physical and social worlds we inhabit. It's fluid, it changes over our lifespan, and it is actively shaped by what we demand of it. I want to leave you with a final thought to ponder as we wrap up this explainer. Knowing that your brain is constantly adapting, how are your daily environment, your habits, and the cognitive challenges you choose to tackle today shaping your own cognitive trajectory for tomorrow? Thank you so much for joining me. Keep challenging your mind, and I'll see you next time.